Welcome to this video on the standardized inverse normal distribution and the RGuroo normal calculator. Let's begin. After watching this video, you will be able to use the normal calculator in RGuroo to find the value or values of the random variable or variables given the probability. Introducing the normal calculator in RGuroo. To access the normal calculator in RGuroo, you need to log into RGuroo.com, go to probability simulation, probability calculator, continuous. Standardized normal distribution example 1, inverse normal distribution. Find the z-score such that the area under the standard normal curve to the left of the z-score is 0.34. So what we want is we want to cut this normal curve in some way such that the area to the left of this cut is 34%, meaning that the area to the right, of course, would be 66%, because remember the total area has to add up to 100%. So in other words, we know the area under the curve. What we need to do is we need to find the z-score associated with this cut. So to do this, we're going to use the normal calculator in RGuroo. So here we are in RGuroo. I've already clicked on probability simulation, then I click on probability calculator, and continuous. So since we're working with inverse normal distributions, the first thing we must do is change or toggle this button. So the first option says we're going from values to probability. In other words, we're going from z-scores to the area under the curve. Now we want to go backwards. We know the area under the curve, and we want the computer to give us the z-score associated with that area. So that's the first thing we have to change, is we have to click on this button. Notice when we do that, the options for this drop-down menu change. So just so you can see, if I click values to probability, my options are below, above, between, and outside. If I click on this second button, then my options become lower tail, upper tail, between tails, and outside tails. So I want right now, if you recall, I want to do a lower tail because I know that the area to the left of this z-score is 0.34 or 34%. So that's what we want. And you know me, I always like my graph, so I'm going to click the graph button. Okay, so let's look at that and see what it gives us. So again, the reason I love my graph is that it shows me exactly what I wanted. I want to make sure that I shaded the correct area. So this z-score is negative 0.41. So the area to the left of the z-score is 34%. And of course, the area to the right would be 66%. And as you can see here, the z-score isn't exactly negative 0.41, right? There's extra digits here, but we, again, usually round our z-scores. We usually round them to 2 decimal places. All right, let's do another example. This one says, find the z-score such that the area under the standard normal curve to the right of the z-score is 0.62. So in other words, here is our normal curve, and we want to cut it in such a way that the area to the right of this cut is 62%, which means, of course, by default, that the area to the left would be 38%. So again, we want to know, what is the z-score? Where do we need to cut the normal curve in order to create this spread? So we go back to RGuroo. Again, we open our menu here. Okay. So the first thing I need to do is, in my drop-down menu, I need to select upper tail, because now I'm doing a right tail test. And again, make sure you have the right button toggled, because we're feeding the probability into the machine and asking for the z-score. So again, the upper tail is 0.62. The area to the right of the z-score is 0.62. Okay, and then here is my nice picture. So the z-score negative 0.31. If I cut the normal curve into 2 pieces, then the area to the right of z equals negative 0.31 is 62%, and the area to the left is 38%. And once again, you can see that we are rounding our z-score to 2 decimal places. If you look up here, you can see more digits, more precision. But again, generally speaking, we round our z-score to 2 digits. So let's do one more example. This time we're going to do a between example. So this is a little bit more complicated. So suppose we have a problem that asks us to find the z-scores. Notice that it's plural. So we're going to find 2 z-scores that separate the middle 70% from the area and the tails in the standard normal distribution. So we have 2 cuts here, right? So the middle, the area in between these 2 z-scores is 70%, and then the area in each tail, well, let's see. Well, 100% minus 70% is 30%. but that 30% is divided equally between each tail. So we have 15 plus 70 plus 15, all together that gives us 100%. So why did I make you do all this silly math? Why are we doing that? Well, unfortunately, the area or the numbers that we're going to have to feed into RGuroo is not the middle 70%, but rather the 15% in each tail. So we want RGuroo to give us this z-score and this z-score. Okay, so let's see if we can make it do that. So again, we go back to our menu. Again, we have this right button toggle button selected where we're going from the probability to the z-score. And this time I'm going to select between tails. So notice grayed out in this box it says lower tail and upper tail. That means that it wants the area to the left of the lower z-score and the area to the right of the upper z-score. So that's why I had to do some extra arithmetic and get 15 and 15. So let's go ahead and hit this button and see if it generates the proper or appropriate picture. Okay, and lo and behold, it does. Right, so the area in the middle is 70%, and it shows you that right here, that the probability, right, or the area under the curve between these two values is 70%, which is exactly what we wanted. And the area to the left of the left tail is 0.15, and the area to the right of the, the upper z-score is 0.15. Okay, so my z-scores respectively are negative 1.04 and positive 1.04. And again, of course, we are rounding our z-score to 2 decimal places. There's more precision up here, but we don't really need that. So, having watched this video, you should now be able to use the normal calculator in RGuroo to find the value or values of the random variable or variables given the probability or the area under the curve.